Hi, this is Suchi and I'm back with another video in the NumPy series. And our today's topic is sorting. How we can apply sorting or how we can sort a NumPy array. So before starting with an example, we have to import the NumPy package in our book. And as usual, we will give it a short name so that we can access all the methods and classes of NumPy package with the short name in. So let me just execute this cell, and now this cell is executed and our NumPy package is available in this code, in this notebook with this short name n. Now let's get into the example. So just let's take a simple one-dimensional array. Here you can see this is a simple one-dimensional array which is having 4 elements, 3, 2, 0, 1, and we want to sort these elements in ascending order. How we can achieve that? So there is a simple method which is named as sort. np.sort, and we have to pass the array here. So if we execute this cell, we can see the original array was this one, 3201, and the sorted array is 0, 1, 2, 3, just what we wanted. Now, this is pretty simple in case of one-dimensional array. What about a two-dimensional array? In case of one-dimensional array, what we have only one axis, which is axis 0. And the elements are sorted along this axis 0. So this sort method also has a second parameter which is called axis parameter. And if we want to specify any specific axis over here, we can do that. So as it is a one-dimensional array, what is the only option for this axis parameter? It is nothing but 0. But if we try to provide some other value here, for example 1, what it will do? It will not give any output, and it will throw an error, as you can see, axis error. So axis 1 is out of bounds for array of dimension 1, because one-dimensional array only has one axis. That axis is axis 0. So axis 1 is not valid for one-dimensional array. That is why we can only provide this value 0 here. One more thing we can provide, that is negative indexing is also allowed here. So if we tell -1, that will take the last axis, and last axis is what? Axis 0 only, because we are having only one axis over here. So last axis or axis 0, this gives us the same output. Now let's increase the complexity by introducing another dimension. So let's move into a two-dimensional array. So here we are having two-dimensional array. By default, it takes axis as -1. What does that mean? If axis value is -1 by default, it will take the last axis for sorting purpose. So if you do not specify any axis value over here, and if we pass the array, this is a two-dimensional array, as you can see. And if we pass this array ARR into this np.sort method without specifying any axis value, it will automatically take the last axis into consideration for the sorting operation. So last axis is axis 1 here, because this is a two-dimensional array. So we are having only two axes, 0 and 1. And 1 is the last axis. So it will sort across the last axis, which is axis 1. So let's see what happens here. So if we execute this one, we can see this was the original array and this is the sorted array. So what exactly it sorted? It has sorted along the axis 1, because here you can see the elements are sorted for individual 1D arrays. Here you can see 3, 2, 4 is being sorted into 2, 3, 4. Similarly, 501 is being sorted into 015. So this is how it can sort a two-dimensional array. And default axis is the last axis. For any number of dimension, the last axis varies. So for two-dimensional array, the last axis will be 1, but three-dimensional array, the last axis will be 2. And for four-dimensional array, the last axis will be what? 3, and so on. So similarly, here also it is taking actually minus one axis, and along that axis only it is sorting the elements. Now, if we want to specify, if we don't want to sort these elements along the axis, last axis, instead we want to sort it along the first axis. Maybe we want to sort the elements. We want to sort these elements, these two, and these two. So what we want? We want 3, 5, 0, 2, 1, 4. Like this, if we want. Then what we can do? We can change the axis of sorting operation. So here, the same thing we are doing. We are trying to sort it over axis 0. If we try to do it over axis 0, what we can get? We will get sorted array along this 0th axis. These two will be sorted, these two will be sorted, and these two will be sorted. That's what we will get. Correct? So, how to do that? We will just specify the axis as 0. So, let's execute this. And what we are getting over here is C. Now, these elements are not being sorted. What is being sorted is these two. 3, 5 is already sorted. So, this is remaining 3, 5. 2, 0 is becoming 0, 2. 4, 1 is becoming 1, 4. So, this is how it is sorting along the axis 0. Now, for axis 1, the result will be similar as axis minus 1 because minus 1 represents the last one and last axis is again 1 because this is a two-dimensional array. So if we execute this one, it will give the same result as we were getting from not specifying any axis value or specifying axis value minus 1. We will get the same result 2, 3, 4, 0, 1, 5. So let us just execute this one and validate our understanding. So we have executed this and we can see this is what we are getting in case of axis 1. And even if we are specifying it to minus 1, we will get the same result 2, 3, 4, 0, 1, 5. So this is how we can change the axis and we can get different result as per our need. Now, what about three-dimensional array? Let's look into one example of a three-dimensional array because in three-dimensional array, we will have 0, 1, and 2, 3 axes. So we have more options. So let us have a look into one example. This is one small function that I have just prepared to print the array in a more readable format. Now, let's look into this three-dimensional array. So this is the array you can see here. And if I do not specify any axis value while sorting it, what it will take? It will take minus 1. So default axis equal to minus 1 will be the value. If axis is minus 1, that means which one? Here we have 3 axes, right? Zero, 1, and 2. And which is the last one? Last one is 2. So here it is 2. Correct? So when we say x is equal to -1 for a three-dimensional array, it means x is 2. That means individual elements of this array will be sorted. That is 1 to 12, this will be sorted. 7, 17, 6, this will be sorted into 6, 7, 17. 16, 11, 3, this will be sorted. 10, 14, 18, this will be sorted, and so on. So let us have a look into the result. So the original array was like this. And if we look at the result, it is as expected. These three are sorted. This is already sorted, so we can see it is same in the result. This is going to be sorted. So 6, 7, 17, 6 is being sorted into 6, 7, 17. 16, 11, 3 is being sorted into 3, 11, 16. 10, 14, 18. It is becoming 10, 14, 18 because this is already sorted. Then again 3, 13, 3, 11, 16. This we have already talked about. Then let's get into this one. 8. Here we can see 13, 8, 16. It is becoming 8, 13, 16. And this one is already sorted, so we can see it as it is. So basically what it is doing, it is sorting around or along the axis 2 or axis -1, whichever we want to tell it. But it can also happen that we want it to be sorted along the 0th axis. That means these three should be sorted, these three should be sorted, these three should be sorted, and these, and these will be sorted individually. If we want something like that, so what we can do, we can specify axis as 0. So we can do this with the help of axis 0. Let me just comment it out. And let us just check what happens if we specify axis 0. So this is the original array, which was having these elements 1, 16, 13. So you can do it very carefully. This is 1, 16, 13. Here we can see 1, 13, 16. Similarly, look at this one, 2, 11, 8. What is it becoming? It is becoming 2, 8, 11. Correct? 2, 8, 11. Now for the next one. Next one is 12, 13, 16. Correct? For 12, 13, 16, 12, 3, 16, sorry. It is becoming 3, 12, and 16. That's it, right? 12, 3, 16 is becoming 3, 12, 16. Similarly, for the rest of the things, it is happening in the same way. 7, 10, 14 is becoming 4, 7, 10, which is sorted. Then 17, 14, 5 should become 5, 14, 17. That's what it is becoming, 5, 14, 17. Now 6, 18, 15 is becoming 6, 15, 18, which is again sorted. So this is how our axis value is helping us to decide along which axis we want to sort our array. So that's it for today, guys. Hope you enjoyed this video. Keep learning, keep implementing. Thank you for watching.